Hello viewers, you are welcome to our series of lectures on complex numbers. I am your lecturer, Professor E.O. Efan. Our first lecture in this series is on the meaning of a complex number and its conjugate. The meaning of a complex number. A complex number is the number written as z equal to x plus iy, where x and y are real numbers and I is an imaginary unit defined as I equal to square root of -1, or upon squaring both sides, I squared is equal to -1. A typical example of a complex number is z equals to 3 plus 2i, where in this case x is 3 and y is 2. The real and imaginary part of a complex number. The complex number z equal to x plus iy consists of two parts, namely the real part written as real part of z equal to x, and the imaginary part written as imaginary part of z equal to plus iy. If the real part x is equal to 0 and y is not equal to 0, then the complex number becomes z equal to iy. In this case, we say that the complex number is purely imaginary. On the other hand, if the real part x is not equal to 0 and y is equal to 0, then the complex number becomes z equal to x. And here we say that the complex number is purely real. Thus, every real number is also a complex number. Example 1. A. Let us simplify I cube. I cube can be expressed as I squared times I using the first law of indices. But I squared is -1. So this will be equal to -1 times I. -1 times I is equal to -I. So I cube is equal to -I. B. I raised to power 4 can be expressed as I squared all raised to power 2. Since I squared is -1, this is equal to -1 raised to power 2. And whenever you raise a negative number to even power, the result is positive. So -1 raised to power 2 is equal to +1. C. I raised to power 5 can be expressed as I raised to power 4 times I. But in B we have seen that I raised to power 4 is equal to 1. So this will give us 1 times I, which is equal to I. So I raised to power 5 is equal to I. D. I raised to power 6 can be expressed as I squared all raised to power 3. Since I squared is equal to -1, so this is equal to -1 raised to power 3. When you raise a negative number to the odd power, the result is negative. So this will give us -1. So I raised to power 6 is equal to -1. E. I raised to power 123 can be expressed as I raised to power 122 times I. But we can express this in terms of I squared as I squared all raised to power 61, then times I. Since I squared is minus 1, this is equal to minus 1 raised to power 61 times I. 61 is odd, so minus 1 raised to power 61 will give us minus 1, then times I. So minus 1 times I is equal to minus I. So that means I raised to power 123 is equal to minus I. F. Let us evaluate 1 all over I. 1 over I can be expressed as 1 all over I times I over I. Then multiplying out the numerators and the denominators, we have I all over I squared. But I squared is minus 1. So this will give us I all over minus 1, which is equal to minus I. So 1 all over I is equal to minus I. Example 2. Express in terms of I. A square root of minus 9. B square root of minus 2. Solution. A. Square root of minus 9 can be expressed as square root of 9 times minus 1. This can further be expressed as square root of 9 times square root of minus 1. But square root of 9 is 3 and square root of minus 1 is I. So this is equal to 3 times I. And 3 times I is equal to 3I. So square root of minus 9 is equal to 3I. B. Square root of minus 2 can also be expressed as square root of 2 times minus 1. This can further be expressed as square root of 2 times square root of minus 1. But square root of minus 1 is I, so this is equal to square root of 2 times I. Square root of 2 times I can be written as I root 2. So therefore, square root of minus 2 is equal to I root 2. Conjugate of a complex number. The conjugate of a complex number z is denoted by bar z, and it is obtained by changing the sign of the imaginary part of z to the opposite sign. Thus, the conjugate of z equal to x plus iy is bar z equal to x minus iy. Observe that this is the imaginary part with plus sign, so we simply change this plus sign to minus to obtain the conjugate. Also, the conjugate of z equal to x minus iy is bar z equal to x plus iy. Here the sign of the imaginary part, which is minus, is changed to plus. Example 3. 1. The conjugate of z equal to 3 plus 2i is bar z equal to 3 minus 2i. The plus sign is changed to minus. 2. The conjugate of the complex number z equal to 6 minus 5i is bar z equal to 6 plus 5i. The minus sign is changed to plus. 3. The conjugate of the complex number z equal to 2i minus 3 is bar z equal to minus 2i minus 3. Please note here that this is the imaginary part, and the sign of this imaginary part is plus here, so we have to change it to minus. Four, the conjugate of the complex number z equal to minus 5i minus 6 is bar z equal to 5i minus 6. Again, this is the imaginary part, and the sign here is minus, so we simply change it to plus to obtain 5i minus 6. We have come to the end of our lecture 1. Thank you for watching, and keep on watching. I remain your lecturer, Professor E.O. Efa.